Welcome, guys, for our talk today. Today, we're going to talk about how to improve Postgres monitoring and observability with Percona Monitoring Tool, PMM. So I'm Charly Batista. I'm a Brazilian that actually lives in China. I'm living in China for a couple of years now. So I work with Postgres and database for over 20 years. And one thing that we always care about is performance, right? We try to understand why the database is performance well or not performance well. And this is what we're trying to understand today. I'll be delivering this talk with my colleague, Agustin Gallego. You can introduce yourself.
Hi, everyone. My name is Agustin. I work as a senior support engineer at Percona. I've been working in the past 8 years there. And yeah, as Charly mentioned, we are always very worried about getting the best out of our servers. Our customers do use PMM a lot and very successfully. And this is one of the main tools that we use to diagnose issues, both like root cause analysis and ongoing performance issues. So back to you, Charly.
OK, thanks, Agustin. So what is our agenda for today? What we're going to talk today? So we're going to try to explain a little bit what's PMM. So that's going to be a short talk. We're going to show PMM interface, how we use PMM for analyzing queries, and what we can get out of those, and what are the OS metrics that PMM can deliver as well, how we can get them. And we're going to go for some metrics on Postgres and how we can extend PMM. One of the major points that we're going to show you guys about PMM is its extensibility. There's a lot of information that you might not find, or information that you have or you would like to have, and you don't find out there on a couple of tools, or even you don't find on PMM. So that's pretty easy. We're going to show how we can extend them and add those new metrics. And by the end, we're going to try to compare PMM with other tools. We're going to show there are many other tools out there, and we're going to see what they have, what they don't have. So why we need an extra tool for monitoring. And we hope we have a couple of questions by the end.
So let's start with a bit of a basic introduction on what is PMM and how it's built, so that when you want to install it and when you want to use it, you will have a better time doing it. So PMM is actually a set of tools that we build, we integrate together, and we offer as a package, with the main focus of it being its ease of deployment and ease of use. So this is all happening in the background, right? You will never need to know that on that Victoria metrics or Prometheus or ClickHouse or even Postgres, because we use Postgres for the backend for storing configuration. You won't need to know that they are there, but it's good for you to do so you can troubleshoot better and be more familiar with the tool. So the easiest deployment here is Docker for the server, and then RPMs or devs packages for the client. So let's talk a bit about the architecture behind PMM. It's a typical client-server application, and we always suggest you to use the PMM client to run as a package inside the database server you want to monitor. This will give you the benefit of having OS metrics that Charly is going to show you, and of course the database metrics. If you don't have the possibility, we have many customers, of course, using RDS, or if you don't have the possibility to install packages, we also have the remote metrics collection available that unfortunately will only get you database metrics, right? So if you can, install the PMM client packages, otherwise there are possibilities. So this is the basic architecture diagram on PMM server. and how it communicates with PMM client. What we need to know is that on the client side, our main interface for managing the client itself is PMM admin. We are going to use commands like PMM admin list, PMM admin add, etc. to check and to add new services. And then on PMM server, you wouldn't typically need to do anything except when troubleshooting. You can get all the logs in a zip file for you to check. So let's quickly go to the last introductory topic, and that's its interface, how we are going to show you the data and what data we have. So it's important to understand that there are 3 levels of depth here. Metrics, the metrics being, of course, the atomic measurement and the points in which we are going to be more focused on. But in PMM, as already mentioned, we already have things bundled so that it's very easy to use and to understand, right? So we work a lot in the graphs that are available and the dashboards, because metrics, as you can imagine, there will be hundreds of metrics, and it's sometimes a bit easy to get lost trying to figure out which ones we need to use for our daily operations or for any problem in particular we want to diagnose. So dashboards are, we try to do them as a consistent view of a subsection of the problem, be it the OS metrics, or be it for instance, what we're going to see, the PostgreSQL instance summary, etc. In them, if we kind of zoom into the metrics, we will have graphs, which are, of course, groups of metrics that are coherently added together, and then we have the atomic measurement of the metric. So this is the home dashboard. If we scroll down, you are going to find out that you have a quick summary report on your environment. So all the nodes that you currently have monitored are going to appear here. And then we will have these fast, let's say, way to access dashboards in the side pane. This is an easy way of traversing all the dashboards we have, and in particular for PostgreSQL, right now we have the overview and the summary dashboards. We are currently working on extending these offer, let's say. In the top left side of the interface, we are always going to have the dashboard that we're in, and then we will have some time range and refresh access menu there. Once we access a particular dashboard, for instance, we are in the Postgres install summary here, we are going to have an additional way to traverse the different dashboards here and even access query analytics, which Charlie is going to show right now.
Well, thanks, Agustin. One of the things that we are always care, as I said, on when you're working with the database are performance. And at Percona, we do care about performance. We're always trying to find a way to optimize and to get the best of performance. And what we've seen along with the time is, even though we spend a lot of time optimizing the configurations, the setting, the box, everything, what gives us the most performance or performance impact are queries by the end. So when you get a huge box, let's say you get 1.5 terabytes memory, 500 CPUs, NVMe SSDs, so you can get a quite good performance out of the box, right? We can go to there, we can check everything, we can optimize, we can change the configurations, we can do a lot. And sometimes we get like 5, 10 times up performance just optimizing those things. But when you get a bad query and do an optimization, sometimes you go for 1 second to 10 milliseconds or 1 millisecond. So we are not talking anymore about 5, 10 times. We are talking about orders of magnitude on performance difference. right? And that's why we always care about query analysis. And on PMM, one tool that we have, and we are always improving, so is the query analysis dashboard. As Agustin said, we try to divide and split the information inside of PMM on dashboards. So getting the dashboards you get for a very specific kind of problems. In this example here, we are going for query analysis. This is the problem we're trying to solve now. So when we're going for the query analysis, what we usually want to see? Well, we want to see the queries, the ones that are running the most, right? What is giving the most of the load for us? Because sometimes you have in your database 20, 30,000 queries per second. So you don't want to look at 20, 30,000 queries per second. You want to look at those 20% of the queries that are going to give you 80% of performance optimization, right? So this is what you always try to do. So then we go here, we can try to take a look, okay, what are the queries that give us the most of the load? Well, we can go for the Postgres logs, or we can just log into the Postgres, right, and collect that information. But when you have a tool that collects and shows you in a better manner, you can explore more. And another thing that is important is aggregating that information. So you might have that information on your logs, and you might have that information in your database, but aggregating that information and keeping that information for later analysis is also very important. And that's why one of the reasons why we also keep those information here. So as we can see here, that's going to show us other queries. On the left side here, we can just tell PMM, look, I don't want to take a look on all my instances because I can have like 100 instances here. So then I'm going to get a really busy dashboard. I just want to take a look on my primary, for example. Oh, sorry. I just want to take a look on my primary, for example. Yeah, it's going to show the primary. And then we can go over the queries. We're going to have a quick demo soon. And most of this information we can get out of the box when we have the PGStat statements from Postgres. So a lot of those informations, they're being collected for PGStat statements. So if we're going to use the query analytics, we need to have that PGStat statement installed on Postgres. So you're always collecting that and pushing from Postgres to the PMM. As I said, we're always trying to improve, right? And this is one way that we're trying to improve. At Percona, we're developing this new tool that's PGStat Monitor. So it's an extension that's built on top of PGStat statement, but we are adding a couple of new features on PGStat Monitor. And some of them are really valuable. For example, if you go on the bottom here, we can see that we're going to have now a histogram. So you can see the time distribution of the query that you are inspecting and analyzing here. You can see from the histogram if you can, like just in visual mode, if you can improve or not, or if it's easier to improve or not. So we also capture and keep time interval grouping. So we are grouping those queries because sometimes you have a query that runs pretty fast. Like 9% of the time during the day, it's running the milliseconds. And then suddenly, it's just start performing 1 or 2 seconds, right? So maybe the query is not the footprint. It's being affected for something. So if you have the time interval grouping in the histogram, you can say, okay, yeah, that query from time to time is not performing well, but it's probably not our footprint. It's something causing that query to go really bad, and that's why you're collecting those informations. So this is another extension that we're building. We're still building. It's still on beta. And one thing that we always highlight at Percona is all the tools that we have and tools that were built, they are open source. So we can go for the GitHub and get the code. If you want to contribute, we're glad to have everybody that wants to contribute and add or fill a bug or create dashboards for PMM, for example. So they are all open source, and we keep them all open source at Percona. Just an example here for the PGStats statement. This is what I was telling. So we can have here a histogram of those information. And shall we put and well, this is PMM. So we have a couple of instances running, actually 2 instances, literally a couple of instances running on AWS. So, and we run a couple of loads on those instances. And as I said, this is the query analysis. So we already get a lot of information if you take a look here. We have information about the loads. We have the counts for the query average time. So we can also add more columns here, for example. Let's say I want the reading blocks. So if we do have for those queries, we don't have that information, but we can add here. It's very customizable. We can just build the tool the way we really want the tool to run, the way the tool goes. So if I pick, let's get one select here, this select, for example, it's going to show us a bit more information. OK, yep. So we can see the count, how many queries per second we're having, the average query time, the load. We can get information about the tables here. Some of those informations here, for example, the query plan, they come from PGStat monitor. And this is important to notice. Some of those information, for example, now on this example here, we're using PGStat statement. So of course, we won't have the query plan for here. So this plan is not available. And we can use, even if we don't have the PGStat monitor for Percona, we can use out of the box using PGStat statement. But some of the more advanced features, let's put on this way, they will be available when we have the PGStat monitor installed. And as Agustin was saying, so we can also have all of those information when you're using your database as a service. So you can get those information from the AWS. So PMM can also collect those information from database as a service. OK, moving on. Oh, thanks, Agustin.
Yep.
Yeah, that was kind of the live demo. So another point, and that's why we put on the second here, is we also need to get some OS metrics, right? So it's very important. Even though, as I said, sometimes we don't get the best optimization, or we don't get so much performance when we're checking the OS metrics, we need to understand what is our load. So this is very important to understand how you can optimize your database. You need to understand how your database works. What is a normal load? What is an overloaded? And there are a lot of symptoms that we can check here when we come to the box itself, when you come to the OS itself. And one information that I really love, that I really like to take a look is to see what I have on my box. So, and this is what we get here. This is a textual information from my server. If I go for this textual information here, I'm going to have just a footprint of my server. I know that my server has 128 gigabytes memory. So I know that I have 32 CPUs. And I can clearly see here that I have a probably problem on my configuration. Well, I have swappiness of 60. What is this problem? And guys, is this like a huge problem and probably like have swappiness at 60? Anybody? Robert? OK, all right. So a lot of people, a lot of admins, they think it's not good to have swap, right? It's a bad problem to have swap. So I have a different take. Swap is a friend, it's not an enemy. High usage of swap is a problem. So when your database or your box or your application server is starting to swap too much, then yeah, you definitely have a problem. Yeah, a mic. We have a microphone. Yep. Now that you finish your coffee.
Well, it started. Okay. All right. I can tell you from my own experience, effective cache size can be overestimated. Swap saves your butt.
Yeah, swap can literally save your butt. As I was saying, a lot of people, they think, okay, I'm going to disable the swap. I won't have any swap. What happens if, for whatever reason, your database runs out of memory, your box runs out of memory? Well, usually, the database on that box is the guy that's using the most of the memory, right? So what the kernel does, the kernel is going to, okay, I'm going to get killed. I'm running out of memory. So I need to kill somebody before I get killed. It's going to check who is using the most of the memory on the box. Who is using the most of memory? Well, our beloved database. The kernel is going to go there and just kill the database. If you had swap in that circumstance, the kernel could say, oh, okay, yeah, again, I can push some to swap. The database is going to slow down a lot. We're probably going to get a lot of alerts. The client's going to complain for, look, my query is now taking a day to run. So then you have a day to go there, check what's going on, and fix the problem on your database server. As Robert said, the swap might save you a butt, right? And this is just one example. Swap in is not a problem. Like if your kernel is putting a lot of things to swap, it's because those things are not being used. Swap out, when it's reading from swap, it's a problem. So, and that's why here I can tell that swappiness of 60 might be a problem for our configuration. We want swap, but we don't want to swap too much, right? So the swappiness is how likely your kernel gonna swap. So it goes from 0 to 100. The higher the value, the more likely your kernel gonna swap. It's good for your desktop, for example, because, well, you don't want to have your RAM used by everything. And sometimes your desktop, your kernel, just put something to really swap for your browser. So it's a good thing. But on the server, you want to use all the bit of memory up to the last drop of juice of memory until you get swapped. That's why we always recommend to have swappiness at 1. But why no 0? Well, some kernels, they have problems, some bugs. Some of them have been fixed. But when you use swappiness of 0, it has a high chance that you won't swap and you're going to get killed from the kernel, the database. Well, this is just one of the information, as I said. So we can go here. We can have like CPU saturation, memory issues. For example, if I go here, well, I can tell that my server was not doing anything from the last couple of minutes, and then something just happened, and I got to use here a lot of CPU, right? So when I understand and when I know my server, I can tell that if it's a problem or not. Well, my server maybe like have some season connections, so from time to time I have some peaks, or may not. We may be under attack, right? So if we always run on the certain number of usage, and then you just have some spikes, well, some things might be wrong. And we can also tell if, for example, I have a CPU-bound server here. In my case, I have most of the situations here, my problems, are because I don't have enough CPU. And the explanation of that is because my data set fits entirely in memory. So because my data set fits entirely in memory, I won't have much I/O problem. If I don't have much I/O problem, I'm going to stress memory and CPU, right? So I know my server because I can tell visually what is going on my servers. So it doesn't mean that I need to be looking at those graphs, at those informations every single day. But they're very useful to let me understand what's happening on my server and let know when I have a problem. And when I have a problem, I can just tell, okay, yeah, I have some spike on context switch. Well, if I have some spike on context switch, I probably have too many connections on my server. Because now the CPU is putting in and out too many threads. So then that's why I have so many context switch. So it's probably I have a connection spike here. And I didn't even look at any database metrics. I'm just looking at the OS metrics. So it's not so important to have the OS. It's very important to know what they're telling you, what is the story of those metrics are telling you. And one thing that we try to put on PMM is to organize them in a way that, yeah, they can tell you a story, and you can understand that story. And if it's not the way that best that you get, so what can you do? You can build your own dashboard. You just move them around, and you build your own dashboard that fits the best for you. Yep, coming back, I guess. Yep. Now we have some Postgres metrics as well.
Thank you, Chino. Okay, so let's check the PostgreSQL dashboards we have. So as we mentioned before, by default, we will have two of them. One is the overview dashboard, and the other is the instance summary. The overview will give us, as it says, is like a bird's eye view of our environment, right? So this is typically used with with all the node names enabled, and we will get a quick run on all of them at the same time, right? So let's get the last 1 hour, and we've been running like a PG bench in the background. So things will be kind of stable and predictable, let's say, right? So it's a TPCC-like benchmark.
Quick question. Can
Yeah.
you switch that to a white background
Yeah.
easily? It might be easier to view. I'm thinking it's a little difficult to view right now.
Yeah, that's true.
Wait, I can't see a bit users. Yes.
Light, yep. Save.
Is it better?
Yeah, oh yeah.
Okay. And let's go back to last 1 hour. So yeah, we will have like a bird's eye view of our entire Postgres fleet. And of course, you can select a subset of them only if you're so interested in doing it. But this will give us general details about all of our instances. So what happens is, for instance, we have auto vacuum disabled. We typically shouldn't, right? Unless you are very aware of what you're doing. If you have auto vacuum disabled, this would be, for instance, red, and you can instantly know that your secondary PostgreSQL server has the auto vacuum disabled. So again, you will have a lot of information here about the high-level overview of your server. So as Charlie was saying, if you are already familiar with the amount of traffic that you have or the amount of workload that you expect from each of them, this is a great dashboard in which you can check the health of your overall Postgres fleet. So let's say that you find that your PG primary server is having an unusual load, and you would like to check more on what's going on, right? So the instance summary would be the next step to go here. And as you can see here, we are going to show you some other dashboards that we have created for some custom metrics that we don't currently have available in our stock PMM, right? So let's select the primary. So in the instance summary dashboard, what we have is a bit of a zoom in into the what we had in the overview. In the overview, we had some generic information, and we can drill much more in here. So instead of having simply the connections, we have the connections and in which state they are, right? So if, for instance, you would have an increase in idling transaction here, you may know that this could lead to issues down the line with the transaction times and the amount of data that you have to keep on due to MVCC and potential issues with AutoVacuum not being able to do its job correctly, right? So the first section has some high-level overview of some important variables, and we try to, in all of our graphs and dashboards, have as much information available to the user as possible. So in case if you are not really familiar with what you are being displayed, you're seeing that what's being displayed, that you can at least read a tooltip and have more information easily available. So if you see this icon in graphs, you can hover over it and you will get more information that will help you guide through what you have. So as I mentioned, we do have a kind of stable workload here, but we can already infer some important information here that this is scanning and returning roughly the same amount of tuples. So at least we can say that we are either using properly indexes or we are just returning all the rows that are being scanned. So the query optimizer is doing its job correctly. And then we have subsections that already give us tips on which are the graphics that are going to be shown. So number of transactions, as we would expect, temporary file usage. And then deadlocks. Conflicts you would have only on secondaries. You have the amount of deadlocks and the logs. So again, as Charlie said, if we see that at some point the number of logs starts to increase as to what we expect, we can dig in deeper, right? And another interesting functionality here is, let's say, that we find this area to be problematic because of the metrics we are seeing. We can zoom in into it, and we will get a more detailed level of information displayed, right? Grafana will show us the average of depending on the zoom level we have, right? So at some point, we would be interested in zooming in and getting more detailed level of information with more accurate information, right? So following, this is, like I mentioned, the instance summary for one of our particular servers. And what we can do, if we need information that is not being presented here, we can extend PMM very easily. And this is one of also our main focus behind making PMM available to users is of extending the functionality, right? So there are two different ways of doing this. We have the custom queries and the text file collector, right? The custom queries, what we are going to have is a YAML file in which we will tell PMM which query we want to run, and we need to detail each of the columns that are going to be returned under kind of semantics behind it, right? And then we have the text file collector, which is a much more powerful tool, but it's also more complex to set up. So in this case, what we are going to give PMM is just a text file in Prometheus exporter language output that they expect to parse, right? So in PMM, we have 3 levels of metrics resolution. That's high, medium, and low. Typically, high would be every 5 seconds. You can go down as much as to every 1 second. And then medium, I think it's 10 seconds by default, and low, it's 1 minute, right? So if you don't expect the metrics to have a lot of variance, you can use the low resolution time. And if you expect otherwise, you can use a higher. So the custom exporters will also be defined by the levels of metric resolution. Okay, so this is an example, and we are going to show some other ones. But this is one we created for being able to correctly size the max wall size configuration variable, right? So as you already know, we have the checkpointer timeout here is 5 minutes, right? So typically, if the wall size is correctly dimensioned, you would only get checkpoints due to timeout, right? If you don't dimension it correctly, you may have unnecessary checkpointing before time. So I don't see the times here, but for sure this is 16 and 18. So this is 2 minutes, and we have the checkpointer running like 5 times between these 2 minutes. We expect it to run only once per 5 minutes, which is the checkpoint timeout. And what we see here is that, okay, our max wall size at that time was 1 gig, but every 5 minutes we are writing roughly 7 gigs. So that points into the direction of the wall size needing an increase in size. So what happens when we increase it? In here we changed it to 12 gigs, and what we expect to see happen. So we don't see any checkpointing activity for 5 minutes, and then at the timeout, when the timeout kicks in, you get the wall flashes that you expect. Okay, so this is something that we added with the text file collector. How do we do it? It's really not that complicated. We get the wall LSN initially, and then what we do is just iterate every 10 seconds, and then update the file that has and here below you have the file with only the information written. So this is the Prometheus, let's say, language definition of how a metrics file should look like. And it's the metric name. Then you have these tags and the values. And you can have a comma here and an undefined amount of tags there. And then finally, the value for that metric. Right? In this case, we defined it as a counter, and it's the number of bytes being written to the logs. Right? So what we do is get the LSN, and every 10 seconds we just calculate the diff with these PostgreSQL functions, and we get the amount of bytes that were written in that time. So the collector will run every, in this case we use the low resolution, the medium resolution, so it will run every 10 seconds and collect this data and graph it and use it to create these graphs, okay? Another thing we can do is, for instance, have information on the replica lag, the secondaries in megabytes, right? So in this case, we used a query. Let me show you first the query. And the YAML file will look like this, right? So it will have the metrics name. Here you have the query. So the query is all of this. And every column should have a specified metrics subsection here, right? So our query returns application name, client address, state, and byte lag. This is a metric that we are going to use, and then we are going to use the client address as a label for that metric so that we can know which replica is having this amount of lag, right? And then, of course, sorry?
We got a question.
Okay.
Just a comment.
Yeah?
Everybody's familiar with Postgres 9.6? We had a contract, had a client. 9.6 was one of their servers in the cloud on Amazon. It did not work. Root cause analysis, Amazon never implemented the function call to report replication lag.
Oh, really?
Yeah.
Well done, well done.
So yeah, this is what we would get in this specific case. And we would also like to mention that you have to have some knowledge on, which is really basic as you can see, on PromQL language, right? This is how we get the metrics out of Prometheus or Victoria metrics, which is what we are currently using. But yeah, this is really basic, and what we are saying here is that we want the instant rate for this metric that applies to this service name, which is what we can get from the, I will show you now in a second, but from the drop-down menu in the dashboard, right? And then just use the interval that we have currently selected, which by default is automatic, so it may be every 5 seconds, or as I mentioned before, if we zoom out, interval will be larger. Okay, so this is, these are the two ways in which we can customize PMM to extend it as we want. And we have more information in this blog post. Sergey worked with a customer to port some of the PMM version 1 dashboards we had. And let me show them real quick. And this is what I was mentioning before that we created, right? So this is the one that has our custom replication lag, and well, let me zoom out a bit because. Okay, and in this case we added also the wall writes as an additional graph there. But basically, what you can get here is that the current rate of writes per checkpoint timeout is at 28 gigs, let's say, with our TPCC benchmark, right? And of course, we are going to checkpoint a bit more than we wanted, but we can easily increase the max wall size, and this will be as expected to run every 5 minutes. We also did a proof of concept on adding some information on table bloat, because we were having some issues with a customer in which the vacuum was not being able to run due to long transactions being transactions being open, and they were having they wanted to detect in which tables they had more issues in terms of disk space underutilized, right? So we have 5 more minutes. Let me show you briefly let's use the table statistics. And in here we can have information on, I mean, check the last 2 days, some more interesting parts here. So we can have information on in-depth per database tuple information, right? And this is all with the added customizations that I mentioned in the blog post, right? So there is really a lot of power into what you can get out of PMM, even if you find that there is no support for what you want in our stock deployment. You can really extend it as you want, and we are glad to even take in those extensions you create, the dashboards you create, the custom exporters, and we can even merge them with what we have upstream and make those available for future use. So let's go back to the slides and briefly discuss what other tools we have.
Well, yeah, that's a question that has always been asked. Why we need a new tool, right? Because definitely there are other tools there. So I just picked a couple of them here. Some of them are open source, others are not open source. And one thing that we found that is not easy, especially on the open source world, is easily to customize. So if you go for old tools like Zabbix, Nagios, and it's not easy to customize. So they are not really focused on the database, most of them. They're just generic tools. They don't have a huge focus on the database. There are some of them that are awesome, actually. So you can use Nagios or Zabbix to monitoring your whole park, network, and all these kind of things. They're really powerful. But when it comes to get details into your database, it's really complex. It's really complicated. Sometimes you really need to use 2, 3, or 4 tools. Sometimes you need to use pgdash and pgadmin to grab some information. You need to go to the database to collect other informations. And one of the main ideas about PMM is to have all the insights that you need from your database, from your servers, from your infrastructure in the single tool, and that is open source. This is a core about PMM and about Percona. We are open source. So our tools, they're open source. As Agustin said, we are glad to get collaboration. If you find something that you need and it's not inside of PMM, and if you want to take a step further and build that dashboard, we're glad to put on the mainstream. If you don't have time, or if you think, well, that's my trouble, you can just, okay, email me. If look, I think this information would be very useful if you could get on PMM. Yeah, we definitely will take a look at that. We're definitely going to spend some time and add in and be able for more collaboration and to the whole community. This is one of the main differences from PMM and all the tools that they're out there. We do have some awesome tools. Some of them, the paid tools, they're really good. They're really good. I've been tried in a couple of them, and they give a lot of insights. But they are not open source, right? It's not only the problem to be paid, because, yeah, well, if you have a good product, and if you need, well, it costs money, right? So you need to get paid. But if you can get that tools open source, that would be awesome. And that's, in my perspective, is one of the major points for the tools that you have out there. Well, we came to the end. In Percona, we stand for evolution. Ease of use, we always try to make things ease of use. And we stand for freedom, as always say here. So we are open source company. All our products you can find on GitHub. They are open source. And we do believe that Percona and Postgres, we are really better together. Well, we're hiring. We are passionate about database. We do love Postgres, but we also have out there other flavors of database. And we are in need of developers, DBAs. So if you are there, if you want to learn more about Percona, more about what we do, we can go for percona.com/careers. So we'll be glad to talk to you. And thank you. Questions? I hope you still have 1 minute or so, right?
I think we can squeeze one in, yeah.
Yeah, I was wondering, for the query analysis, when you aggregate the queries, do you kind of parse out things so more queries could aggregate together, like things from the where clause and stuff like that?
Sorry. Yeah, we do have, let me see if we can go back to the query analytics. You do have a tooltip here that tells you, and if you can see there are parameters there, that those make like a family of queries.
Okay.
So no matter the parameters you have there, this query will be the same if you used where AID equals 1, 2, or 5 million. So.
Okay,
Yeah,
so all right, I wasn't sure if that was a parameter because it was a parameterized query or you parsed it out, but you...
No, it's been parsed out, yeah, yeah. Okay. They've been cleaned and parsed out to group them, as Agustin said, in the family of queries, yeah. And if you're using PGStatMonitor, it will give you a sample of this query with the actual value that you get there from the database, and also an explain of that query with that sample of the parameter.
Yeah.
A completely separate query. Why not? Why isn't something like replication lag and the wall file monitor part of the core?
I'm sorry, I didn't understand the question.
You showed how you had the custom metrics for replication lag and wall file creation. Why isn't that? Why is that customized? Why is it not part of the upstream kind of base?
Because we are currently working on it. Development and the support team were really close together. So as we see the need arising for metrics, if we create them and then we push them to upstream. If we cannot, then we just say we have a need. We open a Jira ticket and we have a need for this, and we work on with the dev team to have it added. This takes a bit of time. So in the meantime, what we do is just create our own custom dashboards and use them temporarily while they are pushed.
Awesome. I think, unfortunately, we are over time, so
okay.
we're going to stop it there.
But we can continue. We have the booth.
Yep.
We have time now. So, yeah.
Yeah, if you want to discuss, you can find us at the booth. And
okay, yeah, but we can continue. Thank you very much.
Thank you so much.